When I start simplifying rational expressions, it's a really good idea to follow a set process to ensure that I get an accurate answer that contains all the parts that I need. So step one, I want to make sure that I factor everything. This means numerator and denominator using methods such as GCF and A is 1 and A is not 1. Step two is find domain restrictions. In other words, look for those values that make the denominator equal to 0. Those are the values I'm not allowed to have in my expression. And step three is I want to reduce common terms. In other words, I look for monomials that are the same on top and bottom. I look for binomials that are the same on top and bottom, and then I can reduce those as I go along. So if I turn my attention over to the first example, and I start to follow my steps, first of all, I need to factor everything. Done. Really easy. It's factored for me, which is a wonderful place to start. Second thing, I want to find domain restrictions. So I look at the denominator. I don't care about the numerator, and I see those three pieces. And each of those pieces is going to give me some sort of domain restriction. So I take the 6x to the third, cannot be 0. If I solve that dividing by 6 and taking a cubed root, I know that x cannot be 0. X minus 2 cannot be 0. So x cannot equal 2. X plus 6 cannot equal 0. X cannot equal negative 6. These are my three domain restrictions, the values I'm not allowed to plug into my rational expression. So once I've found domain restrictions, the last thing I need to do is reduce common terms. So I start by looking at the monomials. The 3 and the 6 are going to reduce just like a regular fraction down to a 1 on the top and a 2 on the bottom. If I have 2 x's on the top and 3 x's on the bottom, I can reduce 2 from each and end up with 1 x on the bottom. And lastly, I look at the binomials, and I notice that there's an x minus 2 and an x minus 2 on the top and bottom, so I can go ahead and reduce those out. The x plus 4 and the x plus 6 have no matching pairs in numerator or denominator, so there's nothing I can do to reduce them. So when I go to write my answer, I take whatever's left on the top, which is just the x plus 4, and I look at the bottom where there's a 2, an x, and an x plus 6. And when I put all those pieces together, that is my reduced rational expression, along with the three domain restrictions that I found. Notice how if I tried to find the domain restrictions from this final answer right here, I would be missing one of them. It would be the part that got reduced, the x minus 2 that canceled out from top and bottom. So that's why I get the domain restrictions before I reduce. If we look at a second example, it can get a little bit more complicated because we look here and we notice that numerator and denominator are not factored yet. So for the sake of time and the sake of space, I'm going to tell you the methods that I would use in order to factor these. On the top, I would use GCF first, take a 2 out from everybody, followed by a equals 1. And on the bottom, I would use just a equals 1. Again, for the sake of space, we're not going to go through and show the factoring. I'm just going to give you the factored form. The numerator becomes 2 times x plus 5, and the denominator becomes x plus 4 times x plus 5. This is my fully factored form. And once I factor, step 2 is to go ahead and find the domain restrictions. So I look at the denominator, and these two pieces are each going to give me one domain restriction. I know that x plus 4 is not 0, and x plus 5 is not 0. So it's easy to see that x cannot be negative 4, and x cannot be negative 5. Once I've found the domain restrictions, I look for common terms, monomials and binomials on top and bottom. The most obvious is the x plus 5s, and I can only cancel one set of those out because there's only one set in both numerator and denominator. And none of the rest of these terms have a matching pair on top or bottom. So that means every one of them drops down into my answer. I get 2 and an x plus 5 on top and an x plus 4 on the bottom. Notice how if I waited till this last step right here to find domain restrictions, I would be missing the restriction that comes from the x plus 5. So that reduced rational expression there, along with my domain restrictions, constitutes a complete answer to simplifying this rational expression.